Hello everyone, it's IT Chill here. Today, I would like to talk about padding. If you recall on block cipher that is in symmetric encryption, you will realize that block cipher algorithm, such as AES, usually accepts 3 block sizes which are 128 bits, 192 bits and 256 bits. However, cryptographers across the globe had fixed the block size of AES to 128 bits. In order to encrypt a message, the message has to be exactly 128 bits in length. If the length of the message is a multiple of 128 bits, such as 256 bits, we can split the message into 2 blocks of message that is 128 bits respectively and encrypt them accordingly. If the length of the message is not a multiple of 128 bits, such as 110 bits and 222 bits, we have to do something to the message. We will need to fill in some publicly disclosable data into the message to make the message length into 128 bits or 256 bits. We encrypt the message that is now in the correct length by filling in publicly disclosable data. We decrypt the cipher text that has been filled with publicly disclosable data. After the decryption, we just need to remove those publicly disclosable data and we can get back the original message. The process of filling in publicly disclosable data into message that is not sufficient in length was called as padding. When we use padding during encrypting a message, we have to think what kind of data we need to put into the message. There are 2 schemes that I know at the moment, which is PKCS5 padding and 0 padding. This is only for educational purposes. There are actual schemes and specifications that was both used and followed by cryptographers. Assuming the block size is 128 bits or 16 bytes, and the message is 24 bits or 3 bytes, we will take the length of the message in bytes. We will then get its remainder after dividing by 16. We will then use 16 to subtract with the remainder. We will then pad the remaining 13 bytes with the last result after 3 operations. Assuming the block size is 128 bits or 16 bytes and the message is 24 bits or 3 bytes, we will pad the remaining message with 0. It does not necessarily need to be PKCS5 or 0 padding, but the padding data can also be repeated in actual message. This is where the problem starts. We need to remove the padding data after decryption. If we do not know the location that the padding starts, we will accidentally remove some parts of the message. If we try to put some data that shows the location of the padding and the length of the padding, someone malicious could remove them. Due to my current limited capability, I do not see any ways that can add padding without having any drawbacks. In block cipher of symmetric encryption, developers usually had addressed on the padding problem. However, if you have to deal with padding as a developer, I recommend you to find alternatives and avoid implementing padding to the message in block cipher. Remember that I said that there is a subtle advantage in stream cipher. Stream cipher is immune to the padding problem. This is another reason why stream cipher is the primary choice in cryptographers and security-related developers. Padding is primarily used in filling the message with data. Another usage of padding is somewhat similar to the use of salt and pepper in dealing with password, except it is in encryption. Any HTTPS-enabled website that you visit has built-in encryption. Imagine that padding does not exist. Do you think it is a good idea that someone knows that you are sending the same password to that website? Luckily, that we have padding or other cryptographic mechanisms, so even though the same password was sent to the website, the middleman will see random encrypted password instead of same encrypted password each time. That's all for today. Thank you very much.